Today we can discuss another topic, that is significant figures. What is meant by significant figure, or what is the idea behind it? For example, when we measure the length of a desk, suppose you have no measuring device in your hand. Approximately you are telling it has a length of 2 meters. When you say it has a length of 2 meters, it is not certain. Sometimes it will be 1.8 meter or 2.1 meter. Approximately 2, that is not certain. Suppose you have a scale with you. If you measure the length of the desk using a scale, now if you consider a meter scale, there are divisions, and the smallest one is 1 millimeter, isn't it? If you measure the length of the desk using that scale, then suppose you got a value 1.81 meter. 1.81 meter means 181 centimeter. So 181 centimeter or 1.81 meter, the last one is uncertain, isn't it? Maybe slightly more than 1.81 or slightly less than 1.81. One is uncertain. So in the case of measurement, there is such an uncertainty related to the last digit always. And by considering this fact, the concept of significant figures developed. But in the case of numbers, for example, number of desks in your class, you can count it and suppose it is 18. There is no uncertainty related to that particular number. 18 is correct. You can see it and you can count it, the 18 desks in your class. There is no uncertainty in it. Such measurements are also there. In most of the measurements, the last digit is uncertain. And based on this, the concept of significant figures developed, and significant figures are meaningful digits which are known with certainty plus 1, which are known with the certainty plus 1, which is estimated, which is not estimated correctly or uncertain. That is significant. So in significant figures, we will consider certain figures as significant. Which are the figures? Certainty figures with the certainty and the last uncertain digit also will be considered in it. And to find out number of significant figures in a given data, there are certain rules. You have to study all these rules very well, then only you can find out number of significant figures. The first one, all non-zero digits are significant. For example, 285 centimeter, all the digits are non-zero. Therefore, number of significant figures, 3. 0.25, 2 and 5 are non-zero digits. Therefore, 2 significant figures. I think the first rule is clear to you. All non-zero digits are significant. Second, 0 proceeding to first non-zero digit are not significant. For example, 0.0052. Here 2 significant figures are the zeros are proceeding to the non-zero digits. They are not significant. Here the number of significant figures 2. Similarly, 0.03, only one significant figure. Is it clear? Zeros preceding the non-zero digits are not significant, no need to count it. Now the next rule. Zeros between two non-zero digits are significant. Zeros between two non-zero digits are significant. 2.005, it has 4 significant figures. These 2 zeros are in between two non-zero digits, therefore they are significant. So total 1, 2, 3, 4. 4 significant figures. The next rule, zeros at the end or right of a number are significant. Zeros before the non-zero numbers are not significant, but zeros at the end or right of a number are significant, provided they are on the right side of the decimal point. They are on the right side of the decimal point. For example, 0.200 gram. It has 3 significant figures. Here the zeros are counted. Which zeros? Zeros present to the right side of the non-zero digit. And it is in the decimal point. But the terminal zeros are not significant if there is no decimal point. For example, 100. It is simply written as 100. There is no decimal point. So it has only one significant figure. But 100 dot, it has 3 significant figures. 100 dot represent the certainty of that number. So it has 3 significant figures. And 100.0 means these 3 are certain and the last 0 is uncertain. So 4 significant figures. There are 4 significant figures in the case of 100.0, 100.0 or 100.0 has 4 significant figures. Such numbers are better represented in scientific notation. So already we discussed the scientific notation, and 100 without a dot can be represented as 1 into 10 raised to 2. So only one significant figure. 100 dot can be represented as 1.00 into 10 raised to 2. So in our homeworks, there are such problems. 500.0 is given. And when you write the answer, most of you write 5.00 into 10 raised to 2. That is not correct. 5.000 into 10 raised to 2. So 100 dot can be represented as 1 into 1.00 into 10 raised to 2. Therefore, there are 3 significant figures. So 1.0 into 10 raised to 2, 2 significant figures. 1.00 into 10 raised to 2, 3 significant figures. So in scientific notation, the digit term, you can count all the numbers if it is 0 or non-zero in the digit term. That will give you the significant figures. Next one, counting the numbers of object. For example, 2 balls or 20 eggs have infinite significant figures, as these are exact numbers and can be represented by writing infinite number of zeros after placing a decimal. 2 egg, that is certain, only 2, not 2.1 or not 1.99. It is 2, that is certain. So we can write infinite number of zeros after 2. That means 2.00000000. That can be continued. 20 benches, that is certain. Therefore, that can be represented as 20.00000000. So it has infinite number of significant figures. Again, that point is repeated in numbers written in scientific notation. All digits are significant. Example, 4.01 into 10 raised to 2 has 3 significant figures, and 8.256 into 10 raised to 5 has 4 significant figures. Here, how many significant figures? First one, 6.005. All the numbers have to be counted because zeros are in between non-zero digits. So 4 is the answer. 6.02 into 10 raised to 23. 6.02 into 10 raised to 23. It is not 1023. 10 raised to 23. 6.02 into 10 raised to 23. And 6.02 into 10 raised to 23, it is in the form of scientific notation. Therefore, how many significant figures? 6.022. 4 significant figures. 4 significant figures. 8,000, there is no dot at the last. Therefore, only 1 significant figure. And pi, what is pi? Pi is equal to 22 by 7. That is equal to 3.1428571. Etc. If you divide it, that will not stop at the 7.1, that will continue. Or you can say there are infinite number of significant figures. There are infinite number of significant figures. Okay, is it clear? 6.0054. 6.02 into 10 raised to 23. 4. 8,001. Pi, infinite number. The reason pi is equal to 22 by 7, 3.1428571, etc. I think it is clear to you. Another example. How many signifiers present in the following? You can consider it as a homework. You may have an idea. The first one, for example, the first one. How many significant figures? Only 2 significant figures. Because the zeros are before the non-zero digits. Only 2 significant figures. I think it is enough for today. You study it well and do the homeworks to understand it. Okay.